The other technique of generating a clock is nothing but with the concept of ring oscillator. We know that oscillator does not have an input, so let's presume the output was for some reason initially 0. So my output was 0, fine. So this was my output, and I'm presuming that each inverter has a delay of 1 nanosecond. So after 1 nanosecond I get a 1, after another 1 nanosecond I get a 0, after another 1 nanosecond I get a 1, after another 1 nanosecond I get a 0, after another 1 nanosecond I get a 1. So after 5 nanoseconds I got my 0 changed to 1. 0 to 1 after 5 nanoseconds. Still the cycle is not over, right? Because I've just reached from 0 to 1. Now I need to reach. 1 is given at the output, so this goes back. After 1 nanosecond I get a 0. After another 1 nanosecond I get a 1, so on and so forth. So I get back my entire cycle. So I started from 0 and I reached back to 0. And this time period was nothing but it took 5 nanoseconds for this and it took 5 nanoseconds for this. So the frequency of operation was nothing but 1 by t, which was nothing but 1 by 10 nanoseconds. And in simple words, what I have to explain here is you don't need to understand the mathematics here. What you need to understand is when you connect odd number of inverters in series with an output and no input given, or ring oscillators are nothing but connecting odd number of inverters in series, you can generate the frequency you want, or you can generate the clock frequency depending on the delay of each of your inverters. So this is one of the other techniques of generating a clock, ring oscillators. Another technique also of generating a clock is nothing but latch based circuit. Here we have already discussed this in the previous clips, a D latch. Here I have called my input D as nothing but clock, and you see it's nothing but a latch. It's an OR based latch, and we already know the working of latch. So suppose this is my clock and we know that it's a D latch. We know that whatever is D, in this case it's called clock, correct? So whatever is D, that would be my phi. So exactly whatever is my clock is my phi, and inversion of my is nothing but my phi bar, which is nothing but this is my output Q and this is nothing but my output Q bar, and this is my input D, which says that Q is equal to D and Q bar is equal to D bar, correct? So this is another technique of generating a clock where you use a latch, give its input nothing but a clock and its output is nothing but phi and phi bar, and you will get a latch based clock generator circuit. There is another way of generating a clock as well, which is nothing but a crystal oscillator. Don't get intimidated by the diagram what you see in the screen. Let's presume that you have an inverter. This is a Pierce crystal oscillator, correct? This is an inverter. Parallel, we know that a crystal oscillator needs to be connected in between the input and the output terminals. So this is my input and this is my output of my inverter, to which I am connecting my crystal oscillator. At the input I am connecting some load. At the output I am connecting some load. And I am just connecting some resistor across this inverter to bias my circuit. So this is nothing but that circuit, and this is the next stage. The crystal oscillator can be drawn as an RLC component. The higher the value of R, the lower the frequency of operation, and depending on the external capacitance also, we can vary the value of our frequency, and the frequency stability will also vary. Remember, I'm just talking in a very layman's language here. The design of crystal oscillator is itself a state-of-art concept, which is again not needed at this point of time. This point of time, what you need to understand is a crystal needs to be connected between the input and the output terminal. And when we draw an equivalent of a crystal, it's nothing but an RLC. The higher the value of R, the lower the value of frequency. Crystal oscillator gives us technically two frequencies, and these are nothing but the resonant frequencies, and it gives us higher frequency stability. In short, once we get a frequency, we know that we can generate a clock. That is what we are looking at in this particular clip from crystal oscillator. So in summary, we saw 4 different methods of how to generate the clock. We saw crystal oscillator, we saw ring oscillator, we saw latch based circuits, and we saw chain of inverters. In the next clip, we are going to study that the clock which is generated needs to be stabilized, and what are the different clock stabilization techniques. Hope you have followed. Stay tuned for further clips, and thank you very much.